Dear students, today we are going to talk about polymerization. This is very important topic of organic chemistry. So in organic chemistry, the word polymerization has a very important role because in organic chemistry, this question is compulsory in CA for your uh, for the coming papers. So please be careful about polymerization topic. So I'm going to start with addition polymers before, then we will be doing condensation polymers. So let's start with what is polymerization. So polymerization is a process by which we combine smaller molecules to have larger molecules. The smaller molecules are known as monomers, and the larger molecule is known as polymer. Hope you understand. So monomers are the simple molecule, just like we have a wall, and the bricks are monomers, and the wall is a polymer. Hope you understand. So we have two main types of polymers: addition polymers and condensation polymers. What are addition polymers? When smaller molecules join together to make a single large molecule. The word single is very important as there is no byproduct formed when a single polymer is formed. So in addition polymers, 2 plus 2 is 4, nothing else. So we may have two or more than two monomers. I mean, thousands of monomers can be there in a one polymer. So similarly, in condensation polymers, when we combine smaller molecules called monomers, they produce a large molecule called polymer. But along with this, we will be having a byproduct. So the byproduct will be water in this case. So condensation polymers are most maybe natural and synthetic, but addition polymers are mostly synthetic polymers. Synthetic polymers mean these are man-made polymers. Hope you understand. So I can again repeat this. Polymerization is a process in which we combine two or more than two monomers to produce a single large molecule in case of addition polymers, but in case of condensation polymers, we will have a byproduct water along with the polymer. Hope you understand. Okay, now let's move ahead. So now we are going to start with the addition polymers examples. So the first example is for addition polymers is polyethylene. So how polyethylene is formed? First, we need to know what are the monomers or simple molecules from which this polyethylene has been formed. So these molecules are ethene molecule. You can see this is ethene, and this is the structure of ethene. Ethene is a unsaturated hydrocarbon in which addition reactions takes place. That is why it undergoes addition polymerization. For example, we have three ethene molecules you can see from this. So in these ethene molecules, you can see there is plus sign between them. You can see this. So when these three monomers will combine, we will be having a single large molecule called as polymer. Hope you understand. Now how these polymers they join together basically. First of all, this double bond will be broken. When this double bond will be broken, then what will happen? Uh, this carbon will combine with this carbon. This carbon will combine with this carbon. And we will be having single bond between all the carbon atoms now. So these three molecules when joined together, both ends are empty. You can see this. You must keep in mind a polymer may have thousands of monomers in it. So monomer is always unsaturated, and mostly the monomers in case of addition polymers, they are unsaturated. But in case of condensation polymers, you will see the monomers may be different. Okay, they are not identical usually. Okay, and here the very important question in the examination which is being asked. Sometimes this polymer is given to you. Sometimes this polymer is given to you. They can ask you mark the repeating unit. So this is how the repeating unit has been marked in front of you, and we will put n sign behind this in as subscript. So this polymer can also be written like this. Just put 3 here and show one monomer and remove their double bond and make the site empty. On this carbon here electron is available, here electron is available. So it can proceed in both direction like this and like this. Hope you understand. Now this polythene is saturated compound now. These monomers are unsaturated. In the past papers in CAI, the question have been asked, do you think the mass of monomers and polymers they change? No, they don't change because the number of atoms remains same. Do you think their empirical formula is same? Yes, their empirical formula is always same. If you simplify them, you will get the same ratio between carbon and hydrogen atoms. Yes. Okay. After this, we have sometimes this question, this polymer is given. He can ask you what is the repeating unit. So you will write the repeat. You will see in the options repeating unit will be given like this. So this is the repeating unit of polyethylene, and this repeating unit when we put double bond here, this will become monomer again. So you must keep in mind whenever monomers combine to make polymer, what changes, what does not change. These are the exam questions. Mass remains same. The number of atoms remains same. Hope you understand. Okay. Next, where this polyethylene is used, you know that in daily life we use it in making shopping bags to carry things in it. So this is available in the market everywhere. You might have seen on daily basis. So shopping bags, carry bags, these are made with polythene. So in the examination, now how this question can be asked? They will give you, like say, they ask you, this is a monomer for the polythene. It will be asked, right, to draw the polymer, you will take 3 molecules at least, make this polymer. Okay, then the next question can be repeating unit. Okay, you will write this way, this is the repeating unit. Then they can ask you compare the properties of monomers and polymers. So monomers are unsaturated, polymers are saturated. Monomers will undergo addition reactions, polymer will go substitution reactions. But keep in mind, in both cases, both are non-conductors because they don't have free moving electrons. Hope you understand. Okay, let's see what other examples are there. Yes, now we have other examples of addition polymers. Uh, this one is polypropene. The same, nothing is difficult here. Just you have to keep in mind ethene molecule in your mind till the end of addition polymers because the main backbone will stay the same like this. 1 minute please. This is the main backbone. This will stay the same. You can see this. Whether it is ethene, there is C double bond C. Whether it is propene, you see why it is a propene. There are 3 carbons, 1, 2, and 3. Between first and second carbon, there must be a double bond. and the CH3, which is third carbon carrying, it should be taken just like as a replacement of hydrogen, which was in ethene. Okay, similarly, this is another propene molecule because it has three carbons. You will not write CH3 on left or right hand side because we have to connect this carbon with this carbon and this carbon with this carbon. So there must be one electron free on these two carbons, then they can make covalent bond with each other so that they can make this polymer. So this is a repeating unit. Just remove the double bond and just connect them just like this. So this means it can extend anywhere, right? Because a polymer is a very big molecule. It may contain thousands of monomers in it. So again, monomers are unsaturated, polymer is saturated. So now move to the next polymer, that is PVC. Other examples are polybutene, polypentene. These can also be made the similar way. For polybutene, you have to take this one. Just put CH3 here, CH3 here, hydrogen here, hydrogen here. This is butene. Just remove the double bond and you see the pattern on the top of these two carbons. All the, just like this in case of, polypropene, there's a pattern like hydrogen CH3, hydrogen CH3. But in this case, the pattern will be all the CH3 at the top. Hope you understand. Similarly, for polypentene, this is the monomer. And you can make the polymer like this. You can write C2H5 here and CH3 here. And this is pentene. We can make polypentene like this. Just remove the double bond and straighten the bonds and write CH3 here, hydrogen here, open it, C2H5, H here, open it. This is a repeating unit. Just put N here. If you take three monomers, then you have to put three here. Hope you understand. This is polypentene. The last, addition polymer today is PVC. In PVC, you can see the monomer is PVC stands for polyvinyl chloride. So again, the backbone is ethene. Just remove one hydrogen of ethene with C6H5. So there are 8 carbon atoms in this molecule, that is uh, vinyl chloride. As you may see, you can say this is phenyl ethene or benzyl ethene. This is a monomer. And how we can make PVC polyvinyl chloride? Sorry, I'm really sorry for that. This will be Cl here. How to replace it? This is for basically styrene. This we have to change all these. Okay, so in this case of PVC, you see it is polyvinyl chloride. So there will be one, we will replace one hydrogen of ethene with Cl, and you see this Cl will be repeated in the polymer, like Cl here, Cl here, Cl here. Hope you understand. So this is our repeating unit. Repeating unit and monomer difference is only of double bond, and but the number of atoms stay the same. And at the same time, type of reactions they undergo, that is different because this is unsaturated. Repeating unit becomes saturated. So PVC is used in making drainage pipes. In the examination, they can just ask you the simple question. What is the application of PVC, polyvinyl chloride? So PVC is used to make drainage pipes. Hope you understand. If you have any question, so this is the repeating unit of, you put CL here, please. So this is the repeating unit for PVC. I would like you subscribe my channel so that I can upload all the videos for you people and you can enjoy and get knowledge and make yourself independent. Okay, Allah Hafiz. Thank you.